Welcome back to another pre-recorded video by Mrs. Jones. We are talking about dimensional analysis today. So this is technically a review topic. Dimensional analysis you've probably seen a lot in your science classes. The biggest aspect of dimensional analysis is we are going to be converting units. So we're going to take units of measure and convert them into different units of measure. So in order to do that, we should know some classic conversions. So I'm gonna write it down. Some of these you should know. If you don't know, I'm a little concerned. So there's a classic 1 foot is 12 inches. If you didn't know that, I'm concerned for your well-being. 1 yard is 3 feet. 1 mile is 5,280 feet. 1 inch is 2.54 centimeters. And then anything that we're talking about in meters, you gotta think multiplying by 100. So like 1 meter is 100 kilometers, or vice versa. 1 kilometer is 100 meters. Same thing, 100 centimeters is 1 meter. So when you're talking about meters, they're always talking about in numbers of 100. So keep these in mind. We will be using them later. So we're going to keep them up here in the corner. Now, the second aspect that we need to remember when talking about dimensional analysis is kind of this idea of when we multiply fractions, how we cross cancel. So we did this a whole bunch when we were talking about rational functions, okay? So for example, if we did a rational function where I had 7x times x minus 2, let's say I had 5 on the top. If I were to multiply this by the fraction x minus 2 over 3, okay, the things that are diagonal and identical, so this x minus 2, they cancel each other out because eventually they'll get divided by each other. And anything divided by itself is 1, leaving us with 5 over 7 times 3 is 21, 21x. So it makes our multiplication a lot simpler. Now we use this same concept when we are talking about units. So say for example, I have 45 miles per hour. A classic, driving your car, we're going 45 miles an hour. If I want to convert this into miles per minute, okay, we're going to use the same idea of fractions to make this happen. So I'm going to rewrite it. I have 45 miles for every, let's turn our fraction on its head, 1 hour. Now I know the thing that I want to change is this hours. Specifically, I want to change hours to minutes. So I have to think about, well, I know that there's 60 minutes in an hour. I am going to organize that so that my hours will cancel out, or they have to be on a diagonal. So if I want it on a diagonal from this, I have 1 hour is 60 minutes. By doing this in a dimensional analysis, our units are the things that cancel out. Instead of canceling out a number, we are canceling out a unit. So then I do all of my math. I do 45 divided by 60 and end up with 0.75, and I use my remaining units. I have miles per minute. So we have successfully converted miles per hour into miles per minute. Setting it up this way is the easiest way to know, am I going to be dividing or am I going to be multiplying? Now, this is one of the more simple of the conversions. Next, we're going to go, we've got 60 feet per second. And we are going to convert that into yards per second. Okay, so once again, I'm going to rewrite it 60 feet per second. Now the thing that changes here is I need to convert my feet into yards. So when I multiply, I know it has to be on a diagonal. My feet have to be on the bottom. Now I'm going to use my handy dandy conversions chart that we talked about earlier. I have 1 yard is 3 feet. Okay, so now my feet cancel out. I can complete my work by putting it in a calculator, and we get 20, and then I'm going to use my remaining units. Now you always go numerator over denominator, so yards per second. Okay, another fairly simple one, but just being very, very careful of where those units are. Are they in our numerator or are they in our denominator? Now, most of the time, you will actually get a conversion where you are being asked to change both of those units. So I'm going 25 miles an hour. I want to know how fast that is in feet per minute. Okay, so now I'm changing both my miles and my hours to different units. We're going to do it the same way. I have 25 miles per hour. Whichever you choose to start with, it does not matter. Multiplication is cool because you're going to move stuff around. So I'm going to start with my hours. I know if I want to cancel it, my hours needs to be on top, and I'm going to have minutes on the bottom. I know 1 hour, 60 minutes. Before I cancel and solve this, I'm just going to go ahead and deal with my miles next. Miles is on the top. If I want to cancel it, miles needs to go on the bottom. Now, if I'm converting miles to feet, I know that 1 mile, using that handy dandy conversion chart that I said you would need, is 5,280 feet. Now I'm going to go out about the process of canceling. Hours cancels with hours. They're on a diagonal. They're gone now. My miles, even though it is not directly next to it, still cancels with my miles. Because remember, if I have something like 3 times 2 times 1, it's the same as 3 times 1 times 2. It's the same as 1 times 3 times 2. When you multiply, you can move everything around. So I could technically take this piece, move it over to this side, and now they're on a perfect diagonal for me to cancel out. So even if they're not right next to each other, you can still cancel them. Anyways, heading back to where we should be. Now I just have to finish my math. If they're on the top, they're getting multiplied. If they're on the bottom, they're dividing. So this ends up being 25 times 5,280 divided by 60, and we get 2,200. And now we do our units with what is left. So miles canceled, hours canceled. The only thing left in our numerator is feet per, and I'm going down, hours canceled. I'm left with minutes. So I have 2,200 feet per minute. Now, why do I care about dimensional analysis when I am talking about radians and trigonometric functions? Okay. The reason we care about dimensional analysis is because we are going to take what is called a revolution and turn it into a radian. So if I said I have 7 revolutions every 3 minutes, okay, Now, when I say revolutions, I mean I have a circle, and a revolution is I start at one point and I go fully around my circle. Okay, that's a revolution. So I'm saying at my speed, whatever it is, I can make 7 full revolutions every 3 minutes. We are going to turn this into radians per second. Okay, we're going to do the exact same process that we were just doing. Turn it into a fraction. So I have 7 revolutions every 3 minutes. Okay, now let's get the easy one out of the way. Let's change our minutes to seconds. Okay, minutes needs to go on top, seconds are on bottom. I know there's 60 seconds in a minute. Now, if I'm talking about revolutions and radians, if one revolution is 1 full circle, think back when we were graphing, when I start and fully go around the coordinate plane, I have gone 2 pi, or I have made a full 2 pi radians around my circle. That is a revolution. So I know that 1 revolution is 2 pi radians. Just call it rad for short, okay? It's the same exact process, except now we have something else to add to our conversions. We have 1 revolution is 2 pi radians. Now I do my canceling. Minutes cancel out, revolutions cancel out. Now, when we write this, just like when we do pretty much anything with radians, the pi is just going to hang out. We're not really going to turn it into a number unless it asks us to turn it into a decimal. And we are going to put it into our handy dandy calculator. 7 times 2 divided by 3 divided by 60. We have 0.07 repeating pi radians per second. Okay. This is the meat and potatoes. Okay. We are mostly just doing dimensional analysis today. Tomorrow, we're going to be using dimensional analysis to talk about different kinds of velocities. So just like in the last video, I'm going to give you some practice problems so for you to do on your own, and then you need to pause so that you don't get to see your answers until you finish your problems. And then I will give you the answers. So you've got 3 problems. The first one is you need to turn 3 miles, turn it into inches. Okay, 3 miles into inches. Number 2, you have 45 kilometers per hour, and you need to convert that into meters per second. This is meters, not miles, okay? And then our last one is you have 3 revolutions per minute, and you need to convert that into radians per second. So these are your 3 problems that you need to do on your own. Pause the video. Welcome back. Hopefully you did these problems and you're here to check your answers. So for number 1, you should have gotten a very large number that I'm not going to say out loud. Do not forget your units, please. Even though this one isn't a speed or velocity, it still has units. Our next one, you should have gotten 1.25 meters per second. And for our last one, 3 revolutions per minute into radians per second. I'm going to go over this one because it's the most important. You need to take your minutes and turn them into seconds. You need to take your revolutions and turn them into radians. Okay. Giving us 0.1 pi radians per second. Okay. All right, good luck on the rest of your dimensional analysis.